Now, in the last recording, I said that infants aren't necessarily aren't experiencing some kind of build-on process in the learning of words from the piecing apart of phonemes in chapter 4 that we read about. But that's not always true. It's not necessarily true. There's lots of evidence that suggests that these two processes are functioning differently in the brain, and that they're not directly related to each other because, for instance, as I said, infants can hear the difference between b and d, but if they see on a switch task that the words are being attributed to the same picture, then they're happy to ignore those differences. So there's obviously something going on here, some dissociation between the distinction of phonemes and the distinction of words, the material from chapter 4 and the material from chapter 5, respectively. But infants can access those statistical stores of knowledge. One piece of evidence that we have for this is described on page 150. You see there in the last paragraph on the page, Catherine Graf Estes. She did a study that used the switch task after infants had been exposed to an artificial language for a few minutes. And when the infants had been exposed to that artificial language, they learned some new phoneme sequences, some new sequences of sounds, right? And they had stored up some statistical probabilities. They knew about when these words should break. They knew that if the beginning of one section of word was combined with the end of another section of word, that it shouldn't, that wasn't, that they had never heard that before, and that it was not statistically probable. So they had sort of built up some understanding of this artificial language. They knew what the sounds were going to be like. They could predict it. And when they performed on the switch task, if the switch task used the words from the artificial language, then they were able to learn the association between that new word and the picture of the new object much better than the infants who were exposed to then in those trials. It was the same infants, but when those infants were exposed to trials using new words that were not used in the artificial language. So this suggests that if you are an infant and you have the ability to calculate transitional probabilities, then you also can use those mathematical probabilities, your knowledge of how sounds come together, as you're trying to learn new words. You can build upon that previous knowledge, but you don't always necessarily. You just can. Further evidence of this is further evidence of the fact that statistics matter in learning words is described in box 5.1, the 30 million word gap. This box is describing the fact that that there's a huge range of words in how much parents speak to their children and how much children are hearing from their parents. So you see in that 1, 2, 3, fourth paragraph down that babies are hearing somewhere between 200 and 3,000 words per hour. Now that's an enormous range. And just to give you a flavor for about how fast that is, when I read, when most people read, the average reading speed is about 200 to 250 words per minute. Sometimes we talk about that same speed, sometimes we speak a little bit faster than that. So that is something on the range of between 1 minute per hour of speaking and 15 minutes per hour of speaking. So the difficulty is that this correlation between the number of I should say that there is a correlation between how much you hear your parents speak and how many words you yourself learn as an infant. If you hear your parents yammering on and on and on, that's a marvelous thing for your development. The more words you hear, the more likely you are to learn them. But children in economically underprivileged homes, so poorer children, they hear fewer words from their parents. This is probably because they spend less time with their parents. Often these parents have to spend more time working outside the home. Oftentimes both parents are working instead of just one. Oftentimes these children are going to daycare where their attention is divided between the attention from adults is divided across lots of other children. And oftentimes it's because these parents who come from poor families themselves have a smaller vocabulary and use fewer words. So we see that for a various number of reasons, children who come from poor families are hearing many, many fewer words. By the time they're 3 years old, they've heard 30 million fewer words cumulatively than have the children who come from college-educated or even working-class parents. So we're seeing that, and that's demonstrated in Figure 5.2 there in that box. This is suggesting that that statistics very much matter. It matters how much you hear speech, even if you don't know the words. Even if you don't know that a string of sounds that are all spoken together are supposed to mean something, it still matters that you hear those words, because you build up some kinds of statistical knowledge in your brain, and you can use that knowledge when you're trying to learn new words. This carries forth, as the box here says, as box 5.1 says, it carries forward throughout people's lives. And these young children who are born to poor parents, they often struggle to learn to read. They have smaller vocabularies throughout their lives, and end up, it compounds on itself, and they end up doing poorer in school throughout their lives because of this poor vocabulary that they have.